Hey everybody, welcome back to our neck of the woods. So as promised in this video, we're gonna get the water softener, the treatment, the well and everything done. And then probably not right away, we won't have water because winter's coming. We don't have heat in the house. We obviously don't want anything to freeze. So hang tight and I'll show you what we got going on. All right, so the well drillers just left and kind of a miscommunication. They did go ahead and set the pump real quick. Unfortunately, I didn't get it on video, but well pumps are just real skinny type pumps like this, maybe 2.5, 3 feet long. The well that we have is 139 feet deep. They set the pump at 60 feet deep. So there's about 20 feet or more of a drawdown that they say that the water's actually sitting up in there. So they ran 1.25 inch or so PVC pipe, screwed it to the well pump, dropped it on down, and then there's a quick connect system where you actually, the blue PVC pipe that's down in there about 5 feet that's going into the house, there's like a brass quick connect that I showed you guys in another video. They got that attached, and basically you just drop it down with a string and it kind of like rolls over and locks in, and then it's all sealed. But they did that real quick. And then again, kind of a miscommunication on what was gonna happen, what they were bringing. They only brought the pump, the piping, the controller, the manifold, and the pressure tank. So I thought they were gonna bring over everything, and again, just not hook up the water actually. So in case everything freezes, nothing would happen. But I wanted them to bring over everything so that way I could just see everything. And the only things I still need are, we've got 2 softener or filtration media type tanks. We've got a brine tank, and then we've got an iron filter. So there's 4 things total that they need to bring over still. Now the game plan is that the 2 kind of softener thingies, filters are gonna go on this wall. The iron filter will probably go on this wall too. And then below the VF controller and the pressure tank here and manifold, that will actually be where the brine tank is that I actually fill up, because that's like kind of short and easy to do. So this is all they brought over. So we're gonna reschedule for next Monday. They're actually gonna run the electric, so they didn't get that done today. But through that conduit going over to the pump and all the way down, obviously we have to have the electric run. So they're gonna have to pull that back out unless they already pre-ran wire. I was down in here looking at this stuff while they were doing that. So we've got to get electric basically to go from the pump over to the controller. And then from the controller, we've got this wire here that is going over to the breaker. Now it looks like they're using a 12-2 wire along with me using a 12-2. Theirs is a lot more flexible, and the wires aren't solid copper. They're actually like the frayed stuff, and there's no neutral apparently. So you're basically just doing a ground and 2 120 volts going to it. So like for my 212 wire, my 240 volt 12-2 wire, we're just using a black and a neutral as 2 hots, and then obviously the ground, which I just got connected. So they wanted me to install that on a 20 amp breaker. So we've got 2 hots again over here, which I should probably put black electrical tape on that. That'll indicate that that white is actually a hot. The ground is obviously grounded. And I'm not gonna install any of this stuff. I'm just mounting it for them so I get an idea where everything's gonna go. I've only got 1 screw in here so far. So we gotta finish mounting this, get the wires up in here, or I'll let them do it. And then we'll get all that hooked up and controlled. And then again, they're 12-2 wire, ground and 2 hots. I think we're gonna come up maybe this wall over here, go up and over so it's all nice and hidden, and then we'll go behind this over here, we'll punch out, and we'll go up through another one of these locations, and that will actually power the thing. And again, the whole point of this controller here is it's a variable controller. So instead of just having that pump out there, which can flow 15 gallons a minute, instead of that having kick on and off and like water hammering, this PEX in here and the manifold and all that stuff, this controller will only tell the pump to increase and decrease its flow needed upon demand. So that way you're really cutting down on that water hammer effect. You don't need a huge pressure tank. As you can see, we only have like a little 6-gallon here, as opposed to one of those like massive blue things that you see taking up room. It's mounted directly to the manifold, and it's just going to make this job install a lot easier and a lot cleaner looking. But it is pretty expensive, I'm not going to lie. I think that controller right there, made by the same manufacturer who the pump's made by, I'm not sure how you say that, but Grundfos, that's who makes everything. This guy is expensive. This is looking at like an entire system. I want to say it's around like $2,600. So that pump's pretty expensive too, at 15 gallons a minute. I think it was probably almost $1,300 alone. So you're looking at probably another $1,000 for this controller. Well, is that worth it? Plumbers out there, well guys out there, you can answer that. But I don't know. I think, again, the install and everything looks a lot cleaner. You're cutting down on that hammer effect, and I think it's just going to look good. So the game plan is we're going to actually 90 the pecs from here and keep it along the bottom, along the trim, since we can go with the trim board down there and go over top of the pipes over there for the radiant. Come down over here, and then we're actually going to come up and change out this here. We're going to change this out for a 90 fitting. So as this gets mounted to the wall over here, there'll be a 90 fitting just shooting straight down. So hopefully that doesn't hurt anything too, to have a 90 over there, a 90 over there, a 90 here, and then you're going to 90 up and get into the manifold and to the pressure tank. So hopefully that doesn't hurt too much at 15 gallons a minute. I don't know how much pressure that does, but that's the game plan. So I'm going to finish mounting the VF controller just so I can see how that looks. And then I guess we'll be back next Monday, and you guys will see the rest of the install. Okay, I lied. Instead of seeing you guys Monday, there's two things I want to do, just because I can. We already talked about where the pressure tank and everything was going to go, and the brine filter. So because the brine filter is not that tall, I don't think it's more than like 4 feet tall, we can go ahead and set the manifold up here. That way it's out of the way. The manifold is close enough to the VF controller because it's got a screw into here for the pressure sensor. I already got that mounted. The wires run up through the wire crimper connector thingies here, and I put a plug in over here, and then the wire for this just goes up through a rubber grommet. So we've got all that ready to go. We're just gonna hang the other bracket here, get it nice and level, and then we're gonna kind of go ahead and soft mount it, because they're gonna have to take every single piece out of there still and put Teflon and everything around it, and I'll let them do that. And then the last thing that we're gonna do today, I don't think I'll get it mounted, we'll see, but we're actually gonna buy our first boiler today. I was looking on Facebook Marketplace and happened to come across a guy that's local. He just has like hundreds of items that he says are crate damaged. And one of them is actually a Rinnai tankless boiler. And Rinnai is who I wanna go with. And basically it's a deal I just can't pass up. It's got some scratches on the outside of the tank that doesn't hurt the integrity or anything. And we're gonna need 2 Rinnais, unfortunately. I did the calculations for the radiant floor for here, the garage, and the main floor. And I think we're gonna be somewhere around 150,000 BTUs that we need. And the Rinnais only go up to 200,000 BTU. So there's no way that if all the radiant was running at the same time that we'd be able to basically take 2 showers, for example, or the dishwasher or stuff like that. So we're gonna need 2 boilers, and for Aaron and I, we probably could get away with 160, which is the smallest Rinnai they make for the boilers, or for the radiant floor heat. And we could probably get away with 160 also, but I was gonna get 180,000 BTU boiler, but this guy is selling the 200,000 for only $900, when even the 160 is about $1,700 or $1,600 plus tax. So no matter what, we're saving like $700-800, and we're stepping up to a 200,000 BTU. So we might as well just save the $700 and get the biggest one they make. And I'm actually gonna go pick it up today, so I'll be back in a little bit with it. He's about an hour-and-a-half drive away. But this Rinnai is an internal circulating pump, 200,000 BTU, propane, and it is a condensating one. So that's the game plan. So real quick, let's just mount this guy up, finish this, and then we'll be back in a little bit with the Rinnai tankless hot water heater. The other reason why I'm doing this is just because I have these 3-inch lag bolts that I already had on hand, so it's not gonna spend any money. And I think I'll do a decent enough job that the well drillers won't mind when they come over and hook everything up. I hit a stud here, but there's no stud right here, but we still have access behind here. So I'm gonna put a piece of 2x4 blocking behind here, so that way we actually bolt to something really strong. So I think the fitting for the controller goes into this adapter that they gave me. That'll go right there on top, so we're really close to the controller. This I think is an overpressure valve. It says 100 PSI on it. We actually have a pressure tank or a pressure gauge so we can read up to 100 PSI. This one's gonna have to be changed out at a later date. This is just like for a garden hose fitting, but you're not allowed to have a garden hose fitting actually on this. This is where they'll actually test the water quality, which to me doesn't really make sense because that is coming from the well and it's not actually testing any of the water purification, unless I'm wrong. We'll have to see what they actually want to do. Maybe these need switched, but again, it doesn't really matter because this is what's going towards all the tanks and stuff. But anyway, you're not allowed to have any threads on a fitting, just in case they don't want you hooking up and like contaminating anything per the county. So once this is all tested and done, this either gets shut off 100% or you have to put this on if you need to relieve the pressure within the system. You actually have to have one of these that's not threaded. It basically just goes to nothing. It's just a smooth shaft. Again, I don't know why the county thinks that way, but you're basically not allowed anything on here. So we'll have to replace this out at a later date for the non-garden hose. But I'm going to let them do all the taping and whatever compound they want to use to close all these in. But at least this is nice and secured now. 2x4s are behind here, although again, this one's in a stud. So this thing isn't going to go anywhere. I can go ahead and screw the pressure tank on. And again, I will let them do all of the taping and everything, but that is how that will look right now. So game plan again that they want to do is run this PEX transition over to the 1-inch white PEX. So I think that's 1.25 inches, and we're gonna go down to 1 inch. And unfortunately, they don't have any of the tools that I want to use for like PEX A, so they're going to use probably this stuff, which is probably PEX C. He says he's got like some $2,000 crimping tool that actually crimps on like a copper fitting. So it's not the PEX A that we're going to use, but we'll show you guys all that at a later time. All right, guys, 3 hours later, back from getting the hot water tank. Seems legit. The guy had a whole garage full of stuff, and he used to work apparently for a plumbing company. So he's got apparently the ins and outs when things get damaged on freight and crate and blah, blah, blah. He brought one out to me that was pretty damaged, and he set it down and he goes, let me get you another one. He actually had, I think, 4 of these that I actually saw. One of them still in the box, but he hadn't pulled it out yet and seen what actual damage there was. But I feel like I got a pretty good deal. So again, we went with Rinnai This is the 199,000 BTU tankless hot water tank. Comes with the manual. I thought this stuff was extra, so maybe we got even more of a deal. So this guy right here, I think is either $1,700 or $1,800. Again, more than what we need, but we still saved like $700 over the 160,000 BTU. But it comes with a wireless controller, which I thought was extra, at least on Rinnai's site it is. And then these fittings for the hot and cold, I thought they were in the accessories section, that they were extra. And it looks like caps for the intake and exhaust, so nothing's getting into your pipes. And then there's another valve on here. I don't know if that's gas or not. I think it is gas. We'll open that up later and look at it. But it should come with everything, but it doesn't. Or at least I didn't think so on the website. So as for the damage on this one, from the front of it, the damage is in the front. So we've got a scuff right here where it looks like the paint was worn away. And then there is a dent right here. I think a little dent over there, and this plastic has a scratch on it right here. So when you pop this cover off and actually do all the service and stuff to it, I'll see if I can push this dent back out and make it look a little nicer. But other than that, that's really just what you're looking at. Everything else, there's nothing broken, nothing chipped off. The sides and everything look fine. Actually, there's a little dent on the side here. There's a dent right there. But we'll open this up and make sure that nothing is actually physically wrong on the inside. And I'll look through the instructions real quick, and we might hang the bracket and just get it up on the wall real quick. Okay, bracket mounted. That is definitely a little higher than I thought we would do, but we are about 63 inches off the ground from the gas line. So if the gas line is going to come on over, I left about 6 inches from the bottom of the tank. So that put the top of that bracket at 95 inches off the ground. So good thing we got 10 feet down here in the basement, or else we would have had to run the gas line with like a drop down type sort of thing. So the bracket up there obviously comes 16 inches wide, so you can go ahead and hit some screws into the stud. We also threw some extra screws in there because there's about 10 holes in that bracket that pretty much let you hit anything. And another good reason why we use the 5/8 particle board. You really have something to screw into and hit it in more places. So this thing's about 68 pounds. So let me get it up there, and once it's hung, then we'll go ahead and put some screws through the top bracket and the bottom bracket, and then that will just hold it a little bit more. So this is going to be fun. Okay, all right, that's nice and squared up. And then to reinsure it even more, there's several more holes in those upper and lower brackets that we're just gonna hit right into the particle board, which that makes me feel a lot better to hang one of these than just screwing in the drywall. All right, I have no idea what I'm looking at on the inside here, except I know over here is going to be the condensation drain. Obviously, we need 110 volt. So over here, I think I still have to put an outlet like underneath or below the controller. Somewhere over here, we can still access to drop down a line. And somewhere over here where the tanks have to sit, they need some power too. But we do have a little bit of a bend here that I think you can see. This side's a little bit straighter. Although right about here, there's a little bit of bend in the frame. So we'll see what we can bend out in the way and kind of get this thing to sit back. But really, I don't think there's a lot that we do in here. I just want to make sure nothing's damaged and none of these pipes are like broken or anything from when this got pushed in. But Looks okay overall. And then here's gonna be the exhaust and the intake. So we're gonna have to bring up some 2-inch PVC up through here, probably come over up in here through the floor joist somewhere. And then like I said, we're gonna get over there and get into the chase up there. And then we can get both these 2-inch pipes out of here. Because even going through here, we're gonna be like in the deck area, and I really don't want that on my deck. Plus I don't wanna drill through concrete. So we'll worry about that in another day. Looks like you got a filter to clean every now and again. And I think you have to recirculate some sort of fluid or cleaning solution through it once a year or two. But we'll go over the instructions, we'll read all that later. But for right now, at least we got it hung, and we can kind of get ready for other stuff down here. So hang tight, we'll be back. Hey everybody, so it's Thursday, it's not Monday yet. The well guys haven't come back out obviously yet. But today I want to get started a little bit on the plumbing for the gas line. So I went to the store, kind of picked up just a whole bunch of everything. All of the fittings and elbows and T's and crosses and copper wire to ground the pipe and some sealant and pretty much everything, the valves, everything. The only thing I don't have is I don't have any of the lengths really. So we're obviously just going to start over here, come in from the outside, 90 over. And then we've got some of these cool brackets that they sit on the wall like that. It's got an internal thread in the middle there. You thread in these guys here, and then there's a clamp that will then clamp around the pipe. So that way you can kind of get your pipe a little bit off of the wall, and you can set the depth for how deep you want to go. Because if you drill a hole through the particle board, you can send that all thread further into the wall, and then you can get your distance right. So we're gonna basically just start over here, work our way this way, and hopefully I got everything. You guys are gonna see this video before the propane guys come out and set everything, so if there's something wrong, please let me know. But the game plan is basically just to come over here and put a main shutoff. Then we're gonna come over a little bit, and then we're gonna tee up to go over to the oven, come over again, tee up, go to the fireplace, and then we're gonna come on down here, and then we can leave a T, or actually we bought a cross for that, to go up into the second boiler, and the bottom of that will be the sediment trap, and then we continue on over here, and then we can get on over to this gas line. Now, I bought at least 5 valves, I think, or maybe 6 valves. So we've got a valve for the main shutoff, we've got a valve to shut off the oven, a valve to shut off the fireplace, and then 2 valves will go on each boiler. So if you ever need to service the boiler, you just shut it down, remove the boiler from the wall. But then I got 1 more valve that will stop right here, and that will shut down each boiler if we have to do anything there. May not end up using that one, but I don't know actually what code is, but let me know if there's anything wrong or that you guys see. So I'm gonna set the camera up and just get started, and we'll go from there. Let's see what happens. All right, I think I've reached the point where I actually have to go to the store and get all my measurements. The only thing I'm not 100% sure on is how sediment traps are supposed to legally work or actually work 100%. So, for example, we know that gas is gonna come over here and it's gonna come into this T fitting on the side there. and then it's gonna go up into the tank, and we got a sediment trap here on the bottom. So the point of the sediment trap is as the gas is flowing through the line, it's gonna come in and hit the back side of this T, and the gas only has two ways to go. It's either gonna go down or it's gonna go up. Well, if it goes up for the gas, then that's what we want. The sediment being heavier iron particles from the inside of this pipe, or when the propane tank, if it's starting to rust out on the inside or something and starting to like release shrapnel pieces, those shrapnel pieces are gonna come through this line, hit the back of here, and because they're heavier, they're gonna drop down into the sediment tank. So for this guy right here, totally easy, 100%, I got no problems doing that. But that's only protecting that tank from sediment. So my idea in the store was we need to get a pipe that comes off of here, runs over to here, and basically hits a cross fitting. So obviously the pipe will just continue on through the middle, and the top here will go up into the second boiler. And I put a sediment trap here, but how is sediment gonna fall down in this trap if the sediment doesn't have anything to bang off of on this side? There's nothing for it to hit. If anything, the sediment's just going to want to continue to travel all the way down till it gets over to this boiler, which again, this boiler is protected by sediment. So I'm not 100% sure if that's even going to work, if someone's just going to say, don't worry about the sediment going up into that one because it's just continuing along. The heavy pieces are just going to shoot through the pipe till it eventually hits a T where it can fall. But maybe code says you have to have a sediment trap, whether it's on a cross or a T. So I'm not 100% sure about that. Someone might also say, why don't you just protect everything before it even gets into the house and put like a sediment trap right here when it comes in? Well, I don't know if they make a fitting for that. I would have to have a fitting that is a 90-degree bend like this one, and then it would have to come out towards you, the camera, and 90-degree bend again. So that way I'm not affecting my width in here from the pipe to the wall, and I still have room to get a sediment trap out here. So I don't know. I'm gonna have to talk to some plumbers maybe and get an idea, but hopefully it doesn't end up being a problem. But like I said, right now for at least, we'll just try to finish it up with getting a pipe measurement now from here to wherever I decide to hang the second boiler, where that cross is gonna go. Then we'll need a measurement from that cross over to here, and then we've got to make a turn, and then one more piece of pipe from here. So that's 1, 2, 3, and then this guy up here, hopefully they make a pipe small enough up in here, because where this laser line is, I told myself I was going to go 6 inches down when I mounted this tank, but where the center of that T is going that way, it only leaves about 1.25 inches from the bottom of this one to the top of that one, and then you can add on however much threads are going in each one. So I think I'm only going to get away with maybe a 2-inch piece. I doubt they make 1.5 inches, because that's just going to be basically all threads and no actual pipe. But hang tight, I'll be back from the store in a little bit with 4 more pieces of pipe, and then at least we can finish this out and get it all kind of stubbed up. And then, like I said, there's no sediment traps here, if you guys are asking, by the way. I didn't put a cross here or a cross here, and that's because as these pipes go up to the fireplace and over to the oven, before they go up into the actual thing, I'll run that pipe up through the floor joist, and I'll put a T right before we put on, we're actually from the bottom of the pipe before it goes up through the subfloor, we'll use yellow flex hose, so that way we can pull the fireplace out and we can pull the oven out. But I'll put a sediment trap down in the floor joist right before the yellow flex pipe goes up through there. So those are not protected here, but they'll be protected right before they go into the unit. Well, I'm back from the store, and before I left, I did a few more things here, but I think I'm going to scrap what I was going to do. I already had one of these union joints, and this is where basically you need to have 2 pipes come together like in different directions. So whether the union goes like right here on the bottom of the tank, or if you're building this way and building this way, you obviously need a union, because you need to spin the pipe this way, you need to go that way, but the pipe needs to spin the opposite way going in here. So obviously you're going to be loosening as you're tightening. So that's what a union joint's for. You can screw your pipe on each end here, and then the middle spins the opposite way, so you can actually bring them together. But again, I was going to have the union kind of in here, so that way I could build over and build over. But problem is I think the tank's too low. So I got a fitting that will go in here, and obviously I'll have to take this apart so I can actually spin the T on. So I can make that work right in between there. But then if you ever try to take all this apart, you're going to have to take all of this pipe off the wall and disconnect from the union here and break it all the way down so that you can get this T to spin off of here. So I think I'm going to take the union, I got about a 3/4 to 1 inch, basically, like it's called a close. So that can go up in there and get really, really tight up in there. Then put a union, and then put another one of those, and one of those little guys right there that will actually go into there down here. But the problem is by the time you put that union on, this tank is going to have to go up several inches. So we do have the room to spare, but that sucks. I gotta take off these screws down here. The ones up there, tank will come off the wall, and then whatever the distance is between here and here, we just have to take the mounting bracket and move it back up those inches. So, but that's the easiest way to do it. You really should have a union joint right here so you can break all this down. And then same thing's gonna go over here. We'll have a little 1 inch union, 1 inch, and then that will go up into this tank over here. All right, everybody, what do you think? That is done for now, except I needed an extra cap here. I put it on the outside so bugs weren't like walking into my pipe right now. But we'll go get one more cap, put this cap on, then we'll take all this apart and we'll do the exact same thing that we did over here. So we've got one more valve, 2 little fittings here, and then the coupling here, and then that way we can break down this tank at a later time. And other than that, I think it looks pretty good. Again, not 100% sure if everything is accurate, but I got enough of these clamps that you can freaking do pull-ups off of this thing. We'll put 2 more of these clamps on the 1/2 inch up there somewhere when that pipe extends on up, so that way that pipe doesn't go anywhere. And putting these clamps here will probably overkill because they're kind of close together, but it's bulletproof. It really is strong. Unfortunately, we won't be able to test it for a few weeks, so we're just gonna leave it here as is, and again, put a cap on this, figure out 2 more 1/2 inch lines, and then I think the fireplace, because it's only 28,000 BTU max, I think we can go 1/2 inch actually down to 3/8 of an inch. So that'll be really easy because we got to go through the floor joist that way, which of course is going to be a huge pain in the butt because I don't want to have a million couplings in between every single joist. So if there's some sort of flexible 3/8 line or even 3/8 iron pipe, maybe it's got a little bit of bend or give to it at, you know, I don't know. I don't know how many couplings we need, but we definitely don't want more than we need. And as far as I know, I don't think I can actually use the yellow flex line to go from here all the way over to the fireplace because I think there's a certain distance, it has to be bonded, and I don't know, got to look in the code on that. But at least for right now, we know we can get to the oven pretty easy because we're going through the floor joist that way. And we got this bonded, so copper wire going down from here, and it's now bonded with the panels wire. So that's copper rods going all the way down to our footer, which was coded in my county. So that it is what it is. So for right now, I'll see you guys back here again on Monday when the well guys come out and we'll start getting this corner finished. Hey everybody, welcome back. It is Monday, November 1st, and the well drilling company is here. They're down into the basement, and as we're getting everything set up, The combines are going out through all the fields now and finally plowing the corn that they had done this year. But again, they're back in the basement, filling everything up. They're running all the lines and getting everything situated. And right now I'm in the basement drilling holes through all of the floor joists. So they've got an 1.25 inch line where the discharge is gonna go. It's gonna go up out of the utility room, go all the way down through the floor joist, and then we're gonna taper it down, going over towards the sump pump area where I've got that connector. My connector is not going to work. I got 1.25 inch like PVC gas line type sizing, and 1.25 inch copper sizing is different. So hopefully they've got a thread that will thread down into the pipe, but will also accept a much smaller 1.25 inch like outside diameter versus like inside diameter type pipe. But I'll go down there and show you guys what we're doing, and then I'm just gonna finish out my drilling, and we'll just keep knocking at it. Justin. Huh?
I'm working the line.
Yeah, once you get it through a joist, that's if I run out, I'll tell you. Okay. Yep. Wait. What's that?
I'm glad you got this hole straight.
That's why the holes are straight.
Because it definitely could have
Even the electric, when you drill a 1/2 inch hole trying to pull even a 15 gauge or a 14-2, it's hard to pull if you don't get the line straight. That's what I was afraid of, getting through this LVL. Luckily, because it is LVL and not solid wood, once you get down to a certain ply, you can kind of break these off one at a time, because getting through 5.5 inches with only a 2-inch hole saw, that's a little difficult. Sweet. A pilot hole punch through so I can go from this side. All right, everybody, they are done. They just left. So if we start over here, this is where basically 120 gallons or so, they said, I think 11 gallons a minute when the iron filters and the softener filters do their regen cycle whenever they're told to, or when they reach a certain amount of water usage. It'll get piped all the way over here and down in. The only thing I'm not 100% sure, and they aren't also, is if this setup's going to work, and that is because there's basically no air in this line. So this could basically get trapped like you know, using a straw and putting your finger over it and you suck up liquid and the liquid stays in the straw and doesn't actually drain out. So we either have to put a trap on here and then run that air up into the floor joist somewhere. So kind of like the washing machine, how it's just kind of like open to nothing, but there is a trap on there. I don't think a trap is needed because water is never gonna permanently stay in here. So we may just use like a sanity to come off, come up, and then up in there, so that way this line and everything can breathe. But we still have to get that line there before we pipe anything up. We still have to get that line out there underground, so that way it gravity flows. That way the sump pump gravity flows all of its water out there, and this thing can gravity flow out there too. So until we get that pipe underground and we can actually test that, then we won't actually know if we need an air gap or not, but we probably will, because again, this basically being a sealed system over to there, over to here, there is air down in that line, obviously, since it's gravity fed out to atmosphere. There will be air up in there until the water starts to flow and completely fills this up. So we just won't know until we test it. But at least we know the check valve's working. Water has never shot out of here, so the sump pump's not shooting the water up. So I'm not worried about water getting all the way pushed back over there from the sump pump, so we're good there. And then as we head into the utility room, this is what we're working with. So if we start over here, they put a 90 on that, going from 1.25 inches down to 1 inch. And that is spaced off of the wall there. I'm gonna go get some more of these brackets and some more of these hangers, but the all thread in there, I'm just gonna have to get a big, like couple foot long stick, and I'll cut my all thread to my own length. So that way, this right here, obviously a 2-inch piece of all thread isn't gonna work right there. So if we put that right about there, it looks like we'll probably need about a 4-inch piece of all thread to go into here and then to clamp onto there. So I'll custom make my all thread again. And then we 90 on over and we 90 on up. And this is what I was talking about, the health department. The health department wants this one that's smooth, that nothing can be attached to. They did leave this one on in case we need to empty this and use a garden hose instead of just opening this one up and standing here with a 5-gallon bucket. I don't know how much water will actually come through here, but 5-gallon bucket should be enough. But technically, if you just put a garden hose on here, we could run it outside, back over through the bedrooms, or for right now, we could even put a garden hose through here until I get this sealed off where the radiant tubes are gonna go through for the garage. But again, all in a later time. And then obviously expansion tank, pressure sensor, 100 PSI max before this opens up and blows out in case the pump malfunctions. Obviously, the pump can go up to 100 PSI. I think they're gonna shoot for around 70 PSI, which this sensor right here will take care of and monitor and watch. And then we come on down into the iron filter, and hopefully the iron filter in here is good enough with, I think it's loaded with green sand. That, I think, is enough to hopefully take out the arsenic and the iron that we have. So the iron that we had was around 1.7 and the arsenic was, I think, almost 16. So both pretty bad. Arsenic, extremely dangerous. So the only way we're going to be able to test out if this works is eventually we're going to have to take a sample from somewhere in the house. For right now, this is obviously going to be the pipe outlet of everything that will go up into the house for cold water, and then we'll come over here for cold water, and we'll actually go up into the boiler. So somewhere on here I may have to put some sort of tap or something, or probably right here actually. I think I can open this guy up right here and actually take a sample of the water that's coming out of there, so we can actually test to see how soft we are, and if we've taken care of the iron and the hardness and the arsenic and everything else. And if that's not been the case, then I'm assuming, since we have so much room right here, we're gonna have to do some modifications. We'll probably have to take this 1-inch pipe here, maybe over here, and come back up here, and then come over, and then we can do some of our whole house filters. So we can come into a sediment, we can come into an arsenic, and we can even come into a pre-iron filter. But right here, that's enough room, especially because of how heavy it is. We've got nice big studs to go ahead into. And then we'll just have to modify this and come over here if we actually, again, need to pre-filter all of this. And that, to me, I think is probably not a bad idea to do already, just due to the fact that if we pre-filter all of this, we know we can bring down the arsenic, we know we can bring down some of the heavy metal, and I don't think the carbon filter and everything is needed, and it's not going to do anything for the hardness. So really just the heavy metal and maybe the arsenic filter. So that way it keeps the iron filter from working so hard, and it keeps these from working so hard. But again, kind of like a pre-filter fabrication there that we could probably do, and that would definitely be easier to change out like once a year, or I think they say 100,000 gallons for those filters, and then we wouldn't really have to worry about overdoing this too much. And then moving on, pressure sensor, so we can constantly stay at our 7 psi on-off valve, so that if we need to service all of this. And then as we're going in here, both of these guys here are the regens. So the iron filter, obviously a lot bigger. That's gonna regen up. I think this is the one that's like 120 gallons. This one I think is a little bit less. But again, they'll both be turned on at different times when they actually have to do their regen. And then all these are just connected, kind of going in, going out. And then water line going over to there and into the brine tank. And this is the salt that they ended up using. They prefer this over what you pick up at like Home Depot and Lowe's, which I think is just Morton salt. And those, I think there's 2 different kinds of Mortons, like iron salt and like regular, just normal salt. So we'll probably use this for a while, and then we'll just figure out just how fast that actually has to use it up, and then we'll figure out if that's too expensive, then we'll try to figure something out. But I am going to wrap this video up here, guys. I am going to wait on my PEX A Milwaukee expansion tool to come in, so that we can come out of here and get over to there, and we can start using PEX A instead of this stuff, because this stuff sucks. It is way too strong, way too hard to bend and maneuver. So this entire house is going to be run in PEX A with just the expansion fittings. So in the next video for the water down in the utility room, we'll go ahead and we'll get all that up. We'll start putting in some branches, or at least the main leg branches that will go down through the house for the hot water and the cold. And because we do have the recirculation tank, which again, if you guys watched previously in the video, I thought this was going to be the $200,000, like $1,700 one, but this is the $2,200 recirculation one. So that makes me feel a lot better that we can recirculate the hot water. And that basically means that when the hot water leaves here, it's going to go all the way down the house, and then it's going to come on back, and then it's going to tie back into a T-fitting and go back up into the cold. So if the water coming out of here is only like 50 degrees Fahrenheit, and we've got to go from 50 degrees up to 120 degrees Fahrenheit, well, if you pipe back in the hot water coming back, because again, this has a recirculation pump inside of it, when it comes back into here, now you've got 50 degree water coming in from here, and then you've got maybe 110 degree water mixing back in. So this also doesn't have to work as hard, and it's going to help with getting hot water on tap faster. So instead of just having the manifold setups, which I know a lot of people are doing nowadays, where you've got a distribution block here, and then out from here you just run 1/2-inch PEX going all the way to your fittings or your fixtures. Well, from here to the master bedroom, I don't think that's going to be a great idea, because you got a 1/2-inch line coming from here going all the way over to the master. You've got to wait for that 1/2-inch PEX line to get rid of all of its cold water because it's been sitting overnight, and you've got to wait 30 seconds, let's say, till your shower starts to get hot. Well, if you do the main branch setup where you're running 1 inch or 3/4 inch line all the way through the house, and then you're teeing off your 1/2 inch lines going up into your bathrooms and stuff, and the hot water is recirculating back, you have almost water instantaneously. So you're wasting less, and you're not, overloading your septic tank because you're constantly wasting more water. So that is the game plan that we're going to do. Again, the distributor box look awesome, and it's nice to isolate each fixture individually. But unfortunately, I think for our house here, it's just going to be better at 50, 60 feet runs. I think it's just going to be better to just do a main branch where we go on down, we come on back, and then the cold water will just go out through this guy. We'll just go on down, and again, we'll branch all the cold waters off. So again, wrapping this video up here. So hope you guys like that what we're using. If you guys have ever seen this before, they like this brand for the iron and for the water filtration. This water right tank's really nothing special. I mean, this is just an empty black thing that's got nothing in it. But let me know what you guys think about this salt or any other salts, and what you think about maybe in the next video when we get it all piped up and hopefully everything works correctly. But we'll see you guys then. So until then, I hope you guys take care. Like the video, subscribe if you're not already, and we'll see you guys next time.